follow along with this video, and you need your reference sheet with the 20 common amino acids and their structures and side chains. I'm just going to go through them and identify the strongest intermolecular force that each can have in interacting with other molecules. I'm going to use the one-letter codes. Alanine, the side chain is just a methyl group. Glycine, no side chain really. Isoleucine, it's just a hydrogen. Isoleucine, the side chain is, I'll draw a squiggle as my backbone. 1, 2, 3, 4 carbon side chain. Leucine, also a 4 carbon side chain. These are constitutional isomers. Proline has that backbone with 3 carbons making a ring around to it. And valine, that V-shaped side chain, the strongest intermolecular forces that any of these can have are nonpolar interactions from dispersion forces, and we can add to this group all of the aromatic, well, most of the aromatic side chains. Phenylalanine, there's the methyl of alanine plus the phenyl group. Tryptophan, should have gone a different direction with it. Tyrosine, like phenylalanine, with a hydroxyl group. Now this one is going to go into a new category. We see the hydroxyl group. This can hydrogen bond. And you can look at all your structures. I'm not going to draw them all, but what else can hydrogen bond? We've certainly got the amides, asparagine and glutamine. We've got the alcohols, serine and threonine. We've got histidine with its NHs. And hydrogen bonding, well, histidine can also have a charge. Histidine can also be positively charged, so I'm going to put that there. But all of these can hydrogen bond. But the groups have to line up just right. You've got to have that H, O, you've got to have that H that gets sandwiched between two O's or between an O and an N. So everything has to line up just right. These are specific interactions. some other specific interactions. If you've got one of the acids that has the carboxylic acid, and I'll draw glutamic acid here. It's usually negatively charged in the body. And the bases and I'll draw lysine here. The lysine side chain. This makes an ionic bond, and it is specific. So I should write out, I wrote it out. A hydrogen bond. These can make hydrogen bonds with each other, and they are specific. There's another type of specific interaction. Let's go back and list these proteins. Glutamic acid and aspartic acid. D for aspartic acid, E for glutamic acid. Lysine gets a K. Arginine gets an R. Sometimes histidine if it has a positive charge. So the plus and the minus can attract each other in the ionic bonds. There's one more type of specific interaction. When you have two cysteine atoms, C for cysteine, we've got our SH, and it can pair up with another SH and be reduced to lose the hydrogen. So it loses H2 somehow, not usually as H2, but we're going to take out an H2, and we then form a covalent bond between the two. This is called a disulfide bridge. And I should give a different name for this ionic bond, because in proteins we call these salt bridges. So we've got our three specific types of interactions: hydrogen bonds, salt bridges, and disulfide bridges. And when you know your functional groups of your different amino acids and have your reference sheet that gives you those functional groups, you can categorize the interactions between amino acids.